There you go. Okay. So good morning to everyone. My name is Fernando, and this presentation is going to be about IPv6 security and also related with IPv4 security. There you go. So as a kind of introduction about myself, I work as a security research for a company called HIP18 Networks. For the last 10 or 15 years, I've been working mostly on communications protocol security. As part of that work, I've been producing security assessment tools and also doing some work at the Internet Engineering Task Force, which is the organization that standardizes Internet protocols. And as part of that work, I have published about 30 RFCs, and over 10 of them are about IPv6, most of them related to security. Before we actually get to the actual topic of the presentation, if you wonder why I don't have any voice, seriously, it's because of this. I was teaching a training course this week. Was a very rough match. And the next day in the morning, I realized I couldn't even speak. Well, at least I enjoyed the match. Hopefully, I will enjoy Saturday, if you know what I mean. Okay. So let's start with a very brief introduction. I realized that, usually in networking environments, you don't need to introduce IPv6, but, I participate in both. I usually also participate in networking meetings, not only security meetings. So since I realized that some people might not be aware exactly what IPv6 is about, I decided to include 2 slides of introduction to get everyone up to speed. So if you wonder what IPv6 is about, essentially you might have heard that we are running out of IPv4 addresses. And in the 90s, there was a protocol called IPv6 that was standardized to actually mitigate this problem. IPv6 provides 128-bit long addresses as opposed to the 32-bit addresses from IPv4. Essentially provides the same service as before, but the little problem, if you want, is that it's not backwards compatible with it. So in a general case, if you have deployed v6, you might end up with a scenario such as this one, in which on the left-hand side, you have a node that only implements v4. On the right-hand side, you have a node that only implements IPv6. And in the middle, what we call Dualstack nodes. Those are nodes that essentially are reachable with any of these 2 protocols, as long as, of course, the node that wants to communicate with it also supports both protocols. The last bit of background is that essentially if you have a system that is dual stack and you want, say, to visit a website hosted on that node, you will usually have A and quad A records. A records obviously holding the IPv4 addresses that we all know, and quad A records, which are the ones that obviously hold the IPv6 addresses. Based on a number of factors, among others, whether everyone on the path supports IPv6, some timing issues too regarding which of the 2 protocols is faster and so on, and system local policy, you might end up using one or the other. Okay, but of course, if you are an attacker and you have a system that is available on both of these protocols, you obviously can select, whichever protocol you let's say is better for you. Obviously, in terms of the security policies. If you wonder, well, who is using IPv6? Because many people have the idea that, well, I hear about v6, but I have no idea if people is using it or not. There's lots and lots and lots of measurements and stats. I just provided this single one, which is the measurements at global scale that are published by Google. So this essentially means that Google, 20% of the traffic that gets to Google, it gets over IPv6, okay? So with this, I'm trying to show a little bit that, it's in production already, IPv6. So let's talk a bit about security policies, okay? We are essentially, what we'll essentially discuss in this presentation is essentially filtering policies. Essentially, V4 and V6 are two different network layer protocols. And while you could have devices that, for example, could allow you to just filter, say, port 80 on both V4 and V6, most of the security devices, and not just security devices, like networking devices in general, they don't allow you to do that. So you have to explicitly configure filtering policies for V4 and for IPv6, okay? Obviously, if you have to do things separately, one from the other, well, that is going to make it quite likely that, people are going to forget about one of them, okay? So essentially, while we would obviously expect the security policies to be the same on both protocols, okay? I mean, the network layer protocol, in essence, it's irrelevant. I mean, you don't care which one you use. Normally, you enforce filtering based on upper layers. What I will try to discuss is, to what extent this is the case. To put it in a different way, if we have a server and that server is available on IPv4 and on IPv6, are the filtering policies the same? So does it make any difference if I try to contact this system over IPv4 versus over IPv6? Obviously, particularly from the point of view of the attacker, that's quite interesting, because if somehow one of the protocols allowed you to do things that the other one didn't, well, that's good for you. So let's take a very brief look at what's the experiment that we did. Essentially, I'm going to obviously just describe only one of the measurements that we did. I mean, otherwise, we'd be the whole day on this. But I think that even when we focus only on one kind of the systems that we measured, it's already illustrative of what the situation is regarding security policies in IPv4 and IPv6. So what we did essentially was to try to analyze the security policies for different kinds of nodes and different kinds of organizations. What do we mean by different kinds of nodes? For example, you might have web servers or boxes whose primary reason is to host websites. We also took a look at name servers, at mail servers, and also at routers. And if you wonder why, why we made a distinction between web servers, name servers, and mail servers, well, if you analyze other configuration aspects, you do find differences already. So essentially, when we were measuring other stuff related with IPv6, we found that the configuration tends to be different. And obviously, if you think about a network, the name server in particular is kind of like a different animal as opposed to, at least, for example, the web server. Not to mention, obviously, the routers that might completely be administered by a different entity or organization. When we did the study, also, we focused on different kinds of organizations, like, for example, companies versus nonprofits versus educational institutions. If you have ever done some kind of like mass scanning, you may already know that usually, for example, universities are a little bit more relaxed than other kinds of organizations. So the idea was to do the same kind of analysis here with like a finer grain detail, if you want. But at the end of the day, the bottom line, what we wanted was to essentially compare the security policies of these two protocols. Again, in theory, they should be exactly the same. In practice, there are already indications that that is not the case. Before I go forward with the experiment that we did specifically, let me mention that there were other studies before the one that we did, and essentially, if you want to summarize them quickly, the authors concluded that when you compare IPv6 systems or networks when IPv4 ones, usually the filtering policies in IPv6 systems and networks are more relaxed. There is a reason for that, obviously. The first network layer protocol that you think about, if you had to configure anything, of course, would be IPv4. And that's the case with usually everything that we use. It's also not unlikely that, for example, you might have some node. It could be a server, it could be a client, could be anything else, and you are used to have that system only use IPv4. So maybe you are not even thinking about v6. Now, for different reasons, including the fact that even ISPs are deploying IPv6 more and more to the clients, well, that situation might change. So the system that you considered as only operating in an IPv4 only world, well, now it might become IPv6 enabled too. As a kind of side comment, this week we had a training on IPv6 security, and among the tests that we did one of them was to essentially enable IPv6 connectivity on what was the local network, okay? And essentially what we did all together was we saw essentially how like a bunch of other systems that were connected to that network that was supposed to be IPv4 only, well, essentially from one moment to another, it became IPv6 enabled too. Maybe they even realized that we were routing some of their packets over the IPv6 internet, and well, with some implications over there. So let's go ahead. Some of the questions that we would like to, or that we wanted to, let's say, to answer or to find out answers about. There are a bunch of things. Like, for example, the idea or the basic idea is that we want to do a comparison about many aspects of the two protocols, starting with some basic stuff like, well, if there's some server that I want to access to, for example, does the server usually have the same number of addresses? Because it could be that it's not the case. Could have multiple addresses on before and only one on IPv6, or vice versa. Then there are other questions, such as, for example, if we have multiple IPv4 addresses, are the filtering policies among those addresses the same? If I have multiple IPv6 addresses, are the filtering policies the same among those v6 addresses? And of course, more importantly, what's the situation when it comes to comparing the filtering policies on IPv4 versus the filtering policies on IPv6? Obviously, the question is if they are the same, and if they are not, if we could conclude that, for example, let's say the v6 world, it's more relaxed in terms of filtering than the IPv4 world. This was essentially the conclusion that other people that had done measurements had gone to, okay? And, it's always, nice for different reasons to redo experiments and try to, check and find out for yourself. So, first thing was how to get, targets, okay? Well, this is just an example. It's not that we did against that, right? But essentially, there are multiple ways to do that. What we did, we also use other things, but one of the things that we did to get a lot of targets was to produce a tool that essentially leverages a search engine to get results. Simply speaking, it's like having a person in front of the browser, going through pages and pages and pages, and obviously you are only interested in those sites that support IPv6. What we did to try to essentially shield different results is put some random stuff on the search field, like few letters or something, so that the results were reordered in a different way. And you get quite a bunch of systems, but not as many as we wanted. So then the next step was to employ a dictionary. I tried a few of the tools that were available. The ones that I did try, we got many, many fewer results. Maybe I just looked at the wrong tools, but this is essentially why we ended up implementing the tool ourselves. Not because we wanted, but because with the other ones that we had, the results were much fewer. So what does this tool do? Essentially, it employs Bing. If you wonder why Bing, because it's the one that is more open. They don't obfuscate the results. They don't ban you when you search a lot of times. We tried all the other ones, or most of the other ones, and all of them had issues. Let's say Google, they obfuscate the results. There's another one called Tioma that, if you do a few searches, your IPv4 address gets banned for like a few days, so the fun is over. So essentially, we got back to Bing, not because we like it, but because it was easier. And this tool, in particular, essentially is the same as the previous tool, but you provide a dictionary, just a text file with a different word in each line. So by obviously going through all the dictionary, you get many, many, many more results. I mean, we don't know, to what extent you can get the whole zone, but the results are pretty, pretty good. This is not the only stuff that we use, but for the web servers in particular, which is what I'm mostly going to discuss today, this is from where we got most of the domain names that we use for the testing. OK, a comment before I get to the other stuff. When you get the results, there are a number of things that you have to do, or that we had to do, to actually provide results that were more meaningful. For example, it's not unusual that among the results that you get lots of Blogger, Blogspot, or whatever it's called, like companies that offer free blogging services for free. So obviously, you want to remove all of those because otherwise, essentially, you're just measuring what Google is doing. Same applies to other content providers. So first, you do like an inspection of the results, and there's stuff that you have to take away. Eventually, when eventually you get to a list that has the biggest content delivery networks out, and you have some results that are good for the measurements. So going to the results, the first of the things that we measure were what are the typical number of addresses per domain name. Okay. As you might see, in this case, it's roughly the same. Not to mention that, another thing that I didn't mention, there's a lot of, let's call it nonsense, put it on the DNS when it comes to IPv6. So you have tons and tons of people that publish, they publish IPv6 addresses on the DNS, but things like loopback, multicast addresses, link local addresses, and so on. So stuff that you couldn't possibly use. That gives you, so I comment, that gives you probably an idea of how clueful or clueless people are about IPv6. But again, when you take all that stuff out, essentially you get similar results for both of the protocols. Also, another thing that we did when I jump to the next one, let's go to the next one and then I do the explanation. Policy. So this is essentially the first, say, big result that we wanted to obtain. What we are showing here on this slide is mismatches between IPv4 and IPv6, and the numbers that you see in the bottom in the x-axis is number of differences. So in terms of ports, so there's about 80% where the policy is the same, okay? But about 20, which is when you add up the rest that you have over there, that there are differences, okay? So the first one that you have is, say, oops, there we go. Differences in a single port, but there are differences in more ports. Another thing that we have to, as I go through the slides, I mentioned some of the things that come to mind while I was doing the measurements. There are networks that essentially, to be honest, I didn't bother to check in so much detail. But when they detect that you are doing a port scan, essentially somehow they respond as everything is open. Or I don't know if they are playing some other trick no matter whether you are scanning or not. So again, there were cases in which we found sites that maybe had over 1,000 ports that were open. So obviously, after finding out those results, it was a matter of also removing them, because otherwise they would change the results unnecessarily. Next. So what do we have here? Essentially in blue, so let's say that we are, again, measuring sites. All of the sites that we are measuring are dual stack, meaning they support IPv4 and IPv6. So what you see in this slide, we are site comment just focusing on the results for web servers, okay? General type of organization, so we didn't split the targets into different kinds of organizations, and we are just focusing on web servers. We have the results for name servers and all the other stuff, plus separating them by the kind of organization, but obviously there wouldn't be enough time. What you see in blue is port numbers, or the percentage of port numbers that are available on both protocols, okay? Which obviously, at least for port 80, 443, and 8443, which is, well, the whole point of these servers, right? They are, of course, for the most part, available on both IPv4 and on IPv6. But if you look at the small part in red in many of these blue bars, well, that's a percentage of sites that have that port number only available on IPv4, but not on IPv6. Okay? Obviously, besides all the security aspects, that is what we are focusing on here, that can also lead to problems when it comes to interoperability, okay? Because somehow you are announcing your server on both of the protocols, but turns out that on one of the protocols it's not available. And if you look, for example, at, let's see, port number 111 or port number 1024 or port number 5666, you can see that on those ones, rather than being a piece in red on top of the blue one, there's actually a piece of yellow. That means, obviously, that there's a percentage of sites that make that port available on IPv6, but not on IPv4, okay? So some of them, when it's more evident that there's a piece in red, that means that, that specific port is available through more, let's say, vectors, not only just Dualstack, but, for example, before. Whereas in the other case, you have some port numbers that they might not be available, for example, on Dualstack on IPv4, but you can reach to them over IPv6. Obviously, since the majority of the ports are available on Dualstack, the difference is not that clear here. So what we have is essentially the same stuff, but now taking out the values of Dualstack, okay? So what you see in blue here is a percentage of port numbers that are only available on IPv4. Obviously, if you look on the y-axis, the percentages are way smaller. We are talking about, let's say, almost a 5%, okay? But what we're seeing is, if you look at some of these cases, for example, port number 21, well, for the most part, there's a big difference when it comes between before and between IPv6. But if you look at other port numbers, say 1024, 3306, which is, as far as I remember, that was MySQL, and the others, well, they are more available on IPv6 than on IPv4. So there's not like a clear rule. It depends on the port. It might also depend on the systems that you're targeting. Okay. Tick. So, conclusions. First of all, there is a significant mismatch between the security policies of the two protocols. In the initial slide, we were talking about something around a 20%, or between 10 and 20%. Of course, whether that's enough or whether that's significant for you, well, depends on your particular scenario, okay? But the important part here is that depending on what's the network layer protocol that you employ, you might be able to access or not access different things, okay? This not only applies to ports where usually you service things for clients, but it also applies to things like SQL, SSH, that you might have available on one protocol, but not on the other. One thing that we found that is different, with other studies that had been made. There was a study published, I think it was in SIGCOMM, a few years ago, authored by Mark Allman, and I don't remember the other authors. And the conclusion essentially was that things were more open on IPv6, which is somehow what I was expecting here. Okay. Now, reading the results, actually, it doesn't seem to be actually the case. So it's not just that IPv6 is more open, so yeah, go on v6 because things are better over there. But based on the results that we got, not the existing ones, it actually looks like there's a mismatch between the security policies in IPv4 and IPv6, but it's not that one protocol is, let's say, weaker in terms of filtering than the other, but there's just a mismatch. So depending on which port number you look at, in one case, it might be better, let's say, from the penetration tester point of view, to use before. In other cases, might be better to use IPv6. One thing that I didn't mention, because the differences are subtle, but that was present in the first questions that I said that we wanted to answer, is that we also check whether there are differences in the filtering policies within a specific family, okay? Let's say that you want to scan one site. Typically what you normally do, you obtain an address for that site, and you just use whatever address you get first, at least if that address is alive, right? So if the address is reachable, you wouldn't normally bother to go through all of the addresses. Somehow you expect that the policies are the same. Now, when we did those measurements on IPv4, essentially we got roughly 100% of same policies for different IPv4 addresses, okay? Meaning, you have a domain name, you obtain, say, 4 addresses, you scan the 4 addresses, you have exactly the same port numbers available on both, which, in some sense, makes sense with our usual practice of just using the first address that you find. But we did the same thing for IPv6, and the results are not exactly like that. It's not that there are big mismatches, so it's not that you get, okay, in 20% of the cases you have different ports that are open, but it's not as precise, or it's not so close to 100% as it is in the IPv4 world, okay? So that would mean or indicate that if the site that you are wanting to scan, let's say, is available on IPv6, somehow you should tell your scanner tool or manually enter the addresses so that you actually go through all of the addresses, because the fact that you didn't find something open in the first address doesn't mean that it is not open on the second address, okay? That's something that I think I don't remember seeing in the other studies that had been published. A final comment, before we get to questions, if there are any questions, is that I wanted to mention 2 specific things, or 2 reasons for which you might end up, or there might be a reason somehow for having mismatch between the two policies. One of them is, as I mentioned, that only a few or a handful of security devices that I have checked, they allow you to enforce filtering policies that are, let's say, agnostic to the network layer protocol, okay? So only few devices allow you to say, okay, just filter port 80 in whatever protocol they are using, on the network layer. All of the other ones are dependent on the network layer protocol, meaning that if you are just used to configuring things of IPv4, it's quite likely that, your network will end up in things like this. So that's one thing. Second thing is that, let's say, if you were aware about these issues and you say, okay, I want to make sure that I filter things on both of the network layer protocols, the support that you might have on your security device might be different from one protocol to the other, okay? Even for vendors that claim that they support IPv6. Obviously, you can take for granted somehow that before it's supported. But even for vendors that claim that they support IPv6, the support might not be, or the support for IPv6 might not be that good. Meaning that Maybe there are features that are just not implemented on IPv6. Or the other thing, which is more tricky, if you want, is that there are a number of vendors that implement, for example, the IPv4 functionality in hardware, but they implement the IPv6 functionality in software. So what does that mean? You might say, well, I don't care about that. Well, you start to care if you're running a network that handles a lot of traffic, okay? Because one thing is what you do in your home network, which you have like impunity to do whatever you please. But if your network handles a sensible amount of traffic, then essentially filtering packets in software is not doable. And there are studies that have been published in which the performance of the box maybe gets to 10% of the performance that they have for IPv4 only. Actually, it degrades. So the more IPv6 traffic that it handles, the more that it degrades. Obviously, when it's processing 100% of IPv6 traffic, in some cases, performance goes like 10%. Performance, I'm talking about the packets per second that they are able to handle, okay? So what I'm saying is that don't assume that in all of these cases, it's just that the admin overlooked the security policies, but there could also be cases in which, for some reason or another, they might not be able to actually enforce the same policy. So I think we are fine. So we have time for questions. You didn't ask, but I will mention one thing. In the event that you are not into networking and you focus on security and you say, well, I don't have IPv6 at home, how the hell do I play with this? There are free tunnel providers, like Hurricane Electric in the US. Well, they provide this service everywhere. So you can actually open a tunnel account for free, and you get to send packets to the IPv6 internet. So it's not that you have to wait for your ISP to enable this, okay? If there are any other questions, you might ask. If not, I'll be around. That's my email address. Emails are welcome. And we also have a mailing list for IPv6 hacking, which is obviously open, and you are free to join. Thanks.